Hey everyone, in previous lecture I already discussed closure of functional dependency. There are set of rules by using that we can find logically implied functional dependency. Some additional functional dependency that can be derived from the original functional dependency. In today's lecture I will discuss closure of attribute set. Suppose A is an attribute and from A we can derive B. Then we can say an attribute B is functionally determined by A. If A can derive to all the attributes of that relation schema, we can say A is the superkey of that relation. So how we'll find that? We can find F plus functional dependency closure, and if left side is same, we can do union of all the right side, and that will be our attribute closure. Let's see the algorithm for functional dependency closure and attribute closure. F plus equals to F. Repeat for each functional dependency F in F plus. F plus means closure of functional dependency. Apply reflexive and augmentation rule of F are the resulting functional dependency to F plus. Then for each pair of functional dependency F1 and F2 in F plus, if both support the transitive rule. Transitive rule means if A implies B, B implies C, then A implies C. Then we can add A implies C to the functional dependency. If F1 and F2 both combinedly support transitive, then we can add resulting functional dependency to F plus, and we'll continue this process until it doesn't change any further. So that is our functional dependency closure. So what we are doing, we are applying reflexive rule, augmentation rule and transitive rule. These are the three main rules of Armstrong axiom, and we are checking continuously is there any logically implied functional dependency possible. If possible, we can add to the functional dependency, and that will be our functional dependency closure. Next, how to find attribute closure. Initially result will be A, our left side attribute. Then for each additional functional dependency we can do union of the right side. So for each functional dependency B implies G in F, do begin. If B is subset of result, then result equals to result union G. So each time we get one new functional dependency, we just add the right side, we just union of the right side, and that will be our attribute closure. For finding functional dependency closure, we are using the rule reflexive, augmentation and transitive repeatedly. There are some additional rules like union, decomposition and pseudo-transitive that we can also apply. And for attribute, we just take union of right side if left side is same, and that will be our attribute closure. Let's see one example. We have set of functional dependency. We need to find AG plus. We have AG, initially result equals to AG. AG plus will be first, it will be AG. Then from A we can derive B, A, B, G. We can add B to AG. We can make union of B and AG. We got ABG. Then from A we can derive C. So we'll make union C with this. It will be A, B, C, G. Then from CG we can derive H. So union of H, it will be A, B, C, G, H. Then from CG we can derive I. So we'll add I. It will be A, B, C, G, H, I. From B we can derive H. H is already there, so we don't need to add. We got A, B, C, G, H, I, which are the all attribute of this relational schema. If we can derive all attributes from that relation schema, then that will be our candidate key. So here AG is the candidate key, as AG positive closure is A, B, C, G, H, I, which are all the set of attributes. So every time we can make a union with the right side if left side is same. There are several uses of attribute closure algorithm. First, for finding the super key. If A plus contain all the attribute in R, then A is the super key. Then we can check if a functional dependency A derive B hold. So how we'll check if B is a subset of A positive closure? Then we can say A derive B means B functional dependent on A hold. We can also check equivalence of functional dependency by using attribute closure. Attribute closure we can use for finding super key, for checking the functional dependency whether it hold or not, to check equivalence of functional dependency. Let's see one example. Example 1. we need to find additional functional dependency, means we need to find the functional dependency closure. From A derive B C, we can write A derive B, that is by decomposition, and A derive C. Okay, then C derive D is given. So A derive C, C derive D. From these two, we can apply the transitive rule. It will be A derive D. Next, E derive F and F G derive H I. Here we can add G. We can write E G derive F G. E G derive F G, F G derive H I. So from these two, we can write E G derive H I. Here we added A derive B, A derive C, we did decomposition, then A derive D, that is by transitive, then EG derive FG by augmentation, then by transitive we can add EG derive HI. In today's lecture, I discussed what is attribute closure, how to find attribute closure, and what are the uses of attribute closure for finding super key, for checking functional dependency, for finding equivalence of functional dependency. We use the attribute closure. In next lecture, I will discuss some more examples of using attribute closure. If this lecture is helpful for you, please like, share, and subscribe. Thank you. Bye bye.